A newly studied particle appears to be heavy enough to defy known physics. A recent study of W bosons reveals that they are far heavier than expected by the standard model of particle physics. The unusual weight of the W boson, one of 17 known constituent particles, may indicate the presence of undiscovered particles or forces. Physicists discovered that a basic particle known as the W boson seems to be 0.1% heavier than it should be. The data originates from a historic particle accelerator at Illinois Fermi National Accelerator Laboratory. If verified, the discovery would suggest the presence of previously unknown particles or forces. The discovery calls into question the standard model of particle physics, which explains all known particles and forces. Other studies have shown less significant outcomes, such as the W boson being a hair heavier than predicted. The standard model is a long-reigning set of equations that include all known particles and forces. It is acknowledged to be insufficient, leaving many major mysteries unanswered, such as dark matter. The W boson is one of two bosons that communicate the weak force, one of the universe's four basic forces. The weak force does not quite so much push or pull as it does change heavy particles into lighter ones. Its mass may be predicted using the standard model equations and a few other observable quantum features. Once researchers obtain precise measurements of the factors that have the greatest influence on the mass of the W particle, then they may detect the weaker influences pulling at its mass. The new mass measurement developed by the CDF team is based on an examination of about 4 million W bosons generated at the Tevatron between 2002 and 2011. The W boson can decay into a neutrino and either a muon or an electron, both of which are easily detected. A cylindrical chamber filled with 30,000 high-voltage wires that measure each particle's route and speed is a critical component of the CDF experiment. They discovered that the W boson weighs 80,433 million electron volts, give or take 9 million electron volts, which is 76 million electron volts heavier than predicted by the standard model. A difference of this magnitude exceeds the 5 sigma threshold that physicists must ordinarily meet in order to declare a definite discovery. The Large Hadron Collider generated more W bosons than the Tevatron, although the increased collision rate complicated calculations of the W's mass. A heavy W boson might be generated by a second Higgs boson that is more aloof than the one we know. It might also be a component of a new composite Higgs made up of several particles, replete with a new force to hold them together. Some theorists believe the particles are those predicted by supersymmetry, a long-studied theory. What do you think this discovery could mean? What are the implications for the standard model of physics? Let us know your thoughts in the comments section.